All right, folks, this is chapter 3-3. This is recording number 1. Okay, let's spend just a minute here, look back on the table of contents for chapter 3. Chapter 3-1, or section 1, was talking about measures of central tendency. That's how things kind of group together. What is it on average? And we had different measures of average, different ways of talking about average: mean, median, and mode. So that was chapter or section 3-1. 3-2, that's the measures of variation. And we had a few different ways of doing that as well. And so now we're in section 3-3. So 3-3 is different, right? I mean, it's a measure of position. 3-1 was like how much does the data tend to, or what's the average? 3-2 was how much are you dispersed? How far apart are you from the average? How far away are you from the median, or excuse me, how far away are you from the mean? Okay, that's 3-2. And now in 3-3, we're going to talk about positioning. So what is your position? Where are you when you're looking at all this data, all of these data points? Where are you? And so that's something that's very important. The typical scenario, typical way you hear this is, your kid comes home, has a score for his homework or for his test, and he says, "Oh, hey, teacher says I did really well. I'm in the top 10%." So that's a measure of position. Okay, all right. So in his little introductory here, he talks about how, in addition to measuring the central tendency and the measuring the variation, we also want to talk about measures of position or location. Where are you in the grand scheme of things? Okay, and here's the different ways we can do it. It's the relative position of a particular data point, the relative position of a particular data value. All right, where does little Johnny lie in the data set? Okay, so for example, if little Johnny is in the 80th percentile, it means that 80% of the kids were below him and 20% were above him. Okay, so that's the 80th percentile. The median is the value that corresponds to the 50th percentile. Half are above, half are below. Okay, all right, so now one of the ways we do this is right here, the standard score. So we're going to talk about standard scores now. This is the expression, you've heard it, I'm sure, in school. The teacher will say, "I'm going to grade on a curve." What he means is he's going to grade using the z-score. Okay, all right, so let's take a look at that. Talking about how you can't compare apples and oranges. If you get a 90 on a music test and a 45 on an English exam, it's very difficult to make a direct comparison, right? The exams might not be equivalent in terms of the number of questions, the value of each question, so forth and so on, okay? But we can make a comparison of a standard as far as where you are with respect to everybody else in the class. How do you stack up with everybody in that particular class? Okay, and this comparison is going to use what we learned in the previous section in order to do it. We're going to use the mean, that's the x bar or the mu. We're going to use the mean, and we're going to use the standard deviation. It's called a standard score. It's also referred to as a z-score. And we're going to use this in later chapters as well. A standard score tells us how many standard deviations a data value is above or below the mean for some specific distribution of values. Okay, so let's take a look at that. Here's the formula. Whatever your particular value is, so that's x right here, that's Johnny's score. Johnny got he got a 90, and the mean was 80. So it's 90 subtract 80, and then that's divided by the standard deviation. Now, this is another example of what I was talking about before, of using a yardstick or a ruler of some sort. The standard deviation is being used as the ruler. So it's a way of measuring things, because if I just said, if I didn't have the standard deviation in the denominator there, if I didn't have the standard deviation down there, I just told you the value, take away the mean. You wouldn't know anything, right? If Johnny comes home and says, hey, good news, Mom, whatever, I'm going to make up the numbers. I got a 90. And you say, oh, yeah, what was the mean? What was the average? And he says, oh, the average was 75. So you'd say, okay, 90 subtract 75. What is that? That's 15, right? I'm not good at arithmetic. Yeah, 90 subtract 75 would be 15. Well, that doesn't tell you anything, right? Okay, you're 15 points above the 15 points above the mean, but what was the distribution like? So if you divide by the standard deviation, it gives you an idea of where you are with respect to everybody else. With respect to the variability of the scores, where is little Johnny? Is he, way up above everybody else, or is he, pretty much in the middle? Okay, so here's the formula for samples. We use the x take away x bar, okay, because that's x bar is the mean for samples. S is the standard deviation for samples, and therefore population we use mu and sigma, because as I've said before, the formulas are a little bit different for the standard deviation S and the standard deviation sigma, so you have to be very cautious there, okay? All right, so the z-score represents the number of standard deviations that a data value or a data point, little Johnny in other words, falls above or below the mean. We're using this standard deviation as a measure, as a yardstick. And then for this section, where we are here, this is section 3-3, we're going to just assume that when we find a z-score, we're going to assume that the data were obtained from samples, okay? So here we go. Here's the example 3-27, test score. You got an 85 on English. The mean score was 76, standard deviation was 4. Where are you with respect to everybody else? So it's x, take away x bar, divided by s. So that's 85, take away 76, divided by 4, gives you 225. And then for the French test, same thing applies, just crank it out. So on the z-score, the English test, you're at 2.25. That's higher than the English test was higher than the z-score for the French test. So you did better. Your relative position is higher. 2.25 is bigger than 2.00, so you're doing better. You're higher up compared to everybody else. All right, so as you can see just by looking at the formula here, if it's a z-score is positive, the score is above the mean. If the z-score is 0, the score is exactly the same as the mean. And if it's a negative number, then you're below the mean. Okay, so I'll let you work your way through this. It's very straightforward, I believe. Okay, all right. Now, when all the data for a variable, when it's transformed into z-scores, this resulting distribution will have a mean of 0 and a standard deviation of 1. Now, why is that true? Well, that's what we were talking about before when we were talking about, the guy that owned the store or the small business and he gave everybody a raise and so forth. That transformation of the data, that's what's going on here is you're transforming this data. The X's here, that's the raw data. That's the actual raw data. When you do this transformation, when you subtract X bar, you're moving the the mean over, and when you divide by standard deviation, you are also you're what we call normalizing it. Okay, so you're normalizing the raw data, the original data. It's translating, it's moving the mean to 0, and when you divide by the standard deviation, you're normalizing it to where the z-scores are going to have a standard deviation of 1. Okay, and then we're going to talk about that a little bit more in chapter 6. Okay, so read that over. That's very important, but we're going to revisit this detail later. We're going to revisit this concept later on. Okay, percentiles, it's kind of tedious, okay? You're just going to have to kind of grind your way through this. It's a position measurement that's used in educational and health-related fields to indicate the position of an individual in a group. So are you in the top 10%? When my son was very young, I was very concerned about his height. You know, he seemed like he was very, very short. So I went to an endocrinologist, and he showed me these charts and says, well, he's not going to be the basketball player, but he's about right. He's, you know, he's okay. He's not that short. So there's an example of, you know, you look at where are you in the percentages? Where are you? What percentile are you at? It's a location measure of a data value. What happens is you divide the distribution into 100 groups is what you're basically doing. And then you're saying, where am I? So here we are. This is the smallest data value all the way up to the largest data value. You divide it into groups, okay? 0.1, 0.2, 0.3, you know, between here and here, that's 1%. Between here and here, that's 1%. So that's what this little cartoon here means. You're dividing into 100 groups, okay? All right. A lot of times they've already been completed. Somebody has done the work on that, and you can use this, you know, to figure out where are you. I'm going to let you read through this. I think it's reasonably straightforward. It's not something we're going to spend a whole lot of time on. Just to be, you know, don't tell anybody, but I'm not going to test you on this. Okay, it's just not. Um, well, I might test you on it, but it's just not an important part of the class. So forget about that. When I said I wasn't going to test you on it, I still reserve that right. Okay, so you kind of go through this here. If you want to find out where the percentile rank for an 11-year-old who weighs 82 pounds. Okay, so here's the curves. Okay, you got the 82 pounds. Boom, there it is. Okay, there you are, 82 pounds. All right, so you go across this away, and then down here you have the age. So 82 pounds, 11 years old. You come up. Where do you meet? You meet right here. You look at that curve. What does that curve tell you? That curve is, boom, right here, the 50th percentile. Okay? This is the 25th percentile. This is the 10th percentile. So wherever you end up, that's where you end up, and that tells you where are you. So the endocrinologist that was looking at my son, that's what he did. Is he but instead of weight, he did it by height. So he had a height and he had an age. He went like this. Boom. He told me what percentile my son was in. Okay, so I'll let you read that. I think it's pretty darn clear. Okay, it's different from a percentile is not the same as percentages. Okay, you get a percentage score. That doesn't tell you very much. I mean, you get a score of 72. Maybe that's really good. Maybe everybody else was down in the 50s, right? You never know. If it's a math exam, hey, a lot of times the math scores are not so good, right? Okay, but you might, if you get a 72, you might still be in the top 10%. All right. So I'm going to let you read that. Uh, okay, so I want to go through this example here to help you out, but I'm almost out of time on this recording. So let me stop this recording, and then on the next recording, we'll talk about example 3-29.